Hello students, do you want to learn how to write RTL code? Today we are starting from the scratch, and by the end of this RTL series, you will be able to confidently write your own RTL code. RTL, Register Transfer Level. RTL is the way of describing how digital circuits move data between registers using logic controlled by a clock. This is explanation. Let us go inside so that we will know clearly what it is. First, in the RTL, let's see what is register. Register is a storage elements like flip-flops, latches that holds the data. For example, like you take a box and we are putting things into it. So register is a storage element. Yeah, next we are going to see transfer. Transfer is moving the data from one register to another. Look at here. Keep A and B as two registers. Moving the data from the register A to register B. For example, let us take two boxes. Moving the things in the box 1 to the box 2. That is transfer. And the next one is level. Level is abstraction level. Abstraction is how detailed we are describing the circuit. That is, the abstraction level is where we describe how data moves between registers using combinational logic and clock signal. For clearer understanding, we have two boxes. We want to move the things in the box 1 to the box 2. So we are giving some detailed information how to move the things in the box 1 to the box 2. That is abstraction level. The RTL is between registers. We are moving the data using some logical operation that is controlled by the clock. The RTL describes how the data moves between registers using logic operations and a clock signal. Yeah, this RTL code can be written using three types of modeling. One is data flow modeling, behavioral modeling, and structural modeling. First, the data flow modeling, it describes how data flows between signals using equation. For the data flow modeling, we use assign and we use equation type. And in the behavioral modeling, it describes behavior using procedural blocks. Here we use always and certain procedure. And in the structural modeling, connecting modules like hardware blocks. Here we use gates and we write the RTL code. Let us see each modeling how we are writing it. The first modeling is data flow modeling. Here it is describing how the data flows between signals using equations. Here it is given as assign y is equal to expression. This is the equation of data flow modeling we are using to write the RTL code. Look at here. For example, we can write it like assign sum is equal to a plus b. In this data flow modeling, we don't have clock and there is no memory. Here, the output updates immediately when the input changes. It behaves like pure logic gates. This assign sum equal to a plus b, it creates a hardware adder where sum continuously reflects the addition of a and b. So in this data flow modeling, we have to keep in mind it is like equation and it starts with assign. And the next one is behavioral modeling. This behavioral modeling describes behavior using procedural blocks. Here you see it uses always. And let's see how the Verilog code is written here. First, let's take always at post edge clock. Look at this. Here post edge is positive edge of clock. That means when clock goes from 0 to 1, at that time block starts running. So the meaning of this is when clock it moves from 0 to 1, the block runs. And Q less than or equal to D. In this, what it says means when clock rises, when it moves from 0 to 1, the values that are stored in D will move to the Q. The Q will hold it until the next clock edge. The Q becomes a memory element. So now look at here. We have to use always in the behavioral, and this post edge clock means that when clock moves from 0 to 1, when clock rises, the value that is stored in the D will be moving to Q until the next clock edge starts, and Q is a memory element. So this is the Verilog of behavioral. Yeah. In the behavioral modeling, we have two types. One is sequential behavioral and combinational behavioral. One is with clock, without clock. Let us look at this. In this, always at post-edge clock. Here, when the clock is rising from 0 to 1, the count plus 1 and it is stored in the count. This is the Verilog code of sequential behavior with clock. Look at this. In the combinational behavior, we are not using clock. So near the always, we don't have clock. It just performs the operation. It is not storing anything. Whenever the input changes, the output automatically changes. So the main difference is with clock and without clock. With clock is sequential, without clock is combinational. With clock, it has storage. In without clock, there is no storage, and it is flip-flops, and here gates are used. And the very important thing we have to keep in mind is, look at here, in this we have used less than or equal to. Here we have used equal to. So less than or equal to are used for non-blocking for sequential, and we have to use equal to for blocking for combination. And the next one is structural modeling. Structural modeling is a Verilog coding style where you build a circuit by explicitly connecting gates or modules to define the hardware structure. Here you see, this is the Verilog of the structural modeling. In the data flow, we used assign, whereas behavioral we used always, and in the structural we use gates, any gates. And here we used and gate, and U1 as instant name, just a label. Y, A, B are connections, that is input and outputs. Now let's see an example. Build a circuit with and plus R gates. That is, the equation is Y is equal to A and B or C. If this is data flow, we will be using assign and we will be doing it. And if it is structural, we use always and we form a certain procedure and do it. Now it is structural, so we need to use gates. So look at this. To write the Verilog code, here the gates used. For this one we use AND gate, and for this we use OR gate and write the Verilog code. So look at this table, students. We have compared all the things. The first one is style. The data flow style is equation based, and behavior style is procedural based, and structural gate based. And keywords for data flow is assign, for behavioral always, and for structural it is gate. And clock used for data flow no, behavioral sometimes it is used, sometimes it is not used, and structural it is optional. And storage, here there is no storage. Here if clock is used we use storage, and only if you instantiate it. So students, these are the basics, and from the next session I'll teach you how to write the basic codes, and then parallelly we'll be moving to the next level codes, and finally we will end it with writing a bigger codes. So if you want to learn all the codings from the scratch, please follow us and subscribe our channel. Thank you.